Hi everyone, I am Prasanna, working as the assistant professor in BVC Engineering College, Waddle Revu. Today I am going to explain about FFT algorithm, that is nothing but butterfly structures. So before going to the topic, see why we are using FFT algorithms to find the sequence of discrete Fourier transform. So to the discrete Fourier transform, it requires n square multiplications and n square minus n additions are required to find the sequence. So for example, take n equal to 8, capital N equal to 8, then 8 square means 64 multiplications and at the same time 8 square minus 8, 56 additions are required if it is DFT. So if we are using FFT algorithm, so then it requires n by 2 log base 2 n multiplications and n log base to n additions. So see here, n by 2 log base to n multiplications and n log base to n additions, that is nothing but it requires 24 multiplications and 24 additions. 12 multiplications and 24 additions are required to find the DFT sequence for the discrete time signals by using FFT algorithm. Okay, so FFT algorithm So FFT is nothing but fast Fourier transform. So fast Fourier transform algorithm is a powerful computational algorithm used to find the DFT sequence of any given discrete time sequence. We are having two types of FFT algorithms. One is DIT FFT and second one is DIF FFT algorithms. DIT FFT and DIF FFT algorithms. So DIT is nothing but decimation in time FFT and DIF is nothing but decimation in frequency FFT. Okay, so FFT is nothing but fast Fourier transform. So both these algorithms having 10 steps to design the butterfly structure and find the DFT sequence for the given discrete time sequence. Before going to that, we know that DFT of any sequence, that is x of n, is given by DFT of x of n is equal to x of k is equal to sigma n equal to 0 to capital N minus 1 x of n e power minus j 2 pi by n into kn. Okay, so here this exponential term can be taken as twiddle factor, that is written as Wn of k. See, so exponential term e power minus j 2 pi by n into k can be written as Wn of k. So see, DFT of x of n equal to x of k equal to sigma n equal to 0 to n minus 1 x of n twiddle factor Wn of k n. So here we are having two powers for the exponential, that is kn. That's why we are writing here kn. But in problems we are using only Wn of k. Okay, next Likewise, for inverse Dft sequence for x of k equal to x of n, that is equal to 1 by n sigma k equal to 0 to n minus 1 x of k e power plus j 2 pi by n into kn. So here exponential term is positive. So twiddle factor is equal to e power w n of minus k n. So likewise we are writing inverse Dft as twiddle factor is w n of minus k n. Remember that inverse Dft formula for can be used in decimation in frequency FFT algorithms, and FFT formula is for decimation in time FFT algorithm. So first see the first algorithm, that is decimation in time FFT algorithm. We are having 10 steps. Our first step is number of samples in the given sequence is represented by n equal to 2 power m. Next, likewise our second step is input samples must be in reversal order and outputs are in normal order. So how we are going to convert the given sequence into reversal order can be seen in problems. And our next step is, third step is number of stages in the structure. So here our formula is m equal to log base to n. So where m equal to integer and at the same time n is nothing but given discrete time sequence. So formula is m equal to log base to n. Our first step is number of butterflies in each stage is given by n by 2, where n is the given discrete time sequence. Our next fifth step is we are having inputs and outputs for the 3 stages. So the input and outputs for the butterflies in each stage is separated by 2 power m minus 1, where small m is nothing but stage index. So here we are having 3, for example take we are having 3 stages. For stage 1 small m equal to 1, for stage 2 small m is equal to 2. Likewise m can be changes depend upon the stages. So our our sixth and seventh steps are multiplications and additions. Already we discussed in introduction. Next, twiddle factor. So for twiddle factor, already I told you twiddle factor formula is w n of k. So here we know n value, that is given discrete time sequence, and at the same time k formula is nt by 2 power m. So where t equal to 0, 1, 2, 3 and so on, 2 power m minus 1. So m is the stage index. Next, 9 and 10 steps. So 9 and 10 steps are used to find the number of sections in each stage and at the same time how many times the factor will be repeated. So the formula is 2 power m minus small m. So already we know capital M is nothing but integer and small m is the stage index. So here also small m will be changes for the stages. So next one is principle of Dft FFT. So actually we are having different butterflies in each stage. So for example A and B can be taken as inputs. So we get the factor wn power k. So we can add these two inputs A plus B into wn of k. So wn of k is nothing but twiddle factor, and at the same time output A minus wn of k into B. So these two are the outputs for the each butterfly.